Now I want to talk about what exactly is strong. When I look at all the acids and bases in the world, I need to know what goes where. And what's interesting is I can kind of draw this sort of diagram here that separates things into those things which are strong acids, those things that are strong bases, those things that are weak acids, and those things that are weak bases, and those things that are nothing. What do I mean by that? I mean that every time you look at a problem, every time you're working an acid-base problem, you have no choice but to put whatever that chemical compound you read is into one of these categories. You will either call it a strong acid, you will call it a strong base, you will call it a weak acid, you will call it a weak base, or you will say that it has no bearing on the problem. That's what you have to do. And what's interesting, and the reason I'm emphasizing this for you right now, is that if you don't do that, you can't get a problem right. That seems obvious. And yet, what is the number one reason students don't get problems right? They learn how to do all the math. They don't have a problem with that, but they refused to learn how to identify the chemical compounds. I'm going to show you what the strong acids, strong bases, weak acids, and weak bases are in just a second. And unless you commit to learning what they are, then you have no ability to do these problems. So absolutely pay attention to, and then whether you like it or not, memorize what goes into these boxes that I'm going to show you.